So we've got a certain SAT preparation school believes that the answers to consecutive questions on the SAT are not independent. Okay, that is, they believe that 2 consecutive questions will have the same answers less than 20% of the time. To investigate, they randomly selected 200 pairs of questions and find that 36 pairs have the same answer. Is this convincing evidence at the 1% significance level that the SAT school is correct? All right, so some information that we want to write down. First of all, this SAT school thinks that the answers are not independent of each other. They believe that 2 consecutive questions will have the same answers less than 20% of the time. So your first job is to write down the numbers from the problem. Okay, so 20%. And that is, what is that as a decimal? 0.2. Okay, so that could represent your P or your P hat. So you're going to have to decide which it represents. Okay, so then it says, to investigate, they randomly selected 200 pairs of questions, and they find that 36 pairs have the same answer. What can I write from that information? 36 out of 200, okay, which is 0.18. And what do you think that represents? Now, does that represent P hat or P? Okay, this is for sure our P hat. We just randomly sampled 200 pairs of questions to see if they had the same answer. And we found that 36 of them did. So what does this value have to be? What must that be? That must be P, the true value. Okay, that must be the true value. Okay, so this is what we're going to use in our hypothesis, the 0.2, and this is what we're going to use in our probability statement. So the 1% is another number in the problem, and that's 0.01. What is that? Significance level.
Alpha.
Very good. That is our alpha. This is what, after we do step 3, this is what we, step 4, we compare our p-value to. Okay, this is what we compare our p-value to in step 4. Okay, so step 1. Now, would you agree that if it's, okay, they believe that 2 consecutive questions will have the same answers less than 20% of the time. Okay, that's what they believe. So, would you agree that our sample does in fact show that less than 20% of the time pairs of consecutive problems have the same answer?
So far. Yeah.
Out of the, in our sample, was this less than 20%? Yes. So when you're doing step 1 for a hypothesis test, the first thing you're going to say is, at first glance, it appears that the true proportion of pairs of SAT questions with the same answers is less than 20%. Okay, why do we think that? Because our sample was less than 20%. So at first glance, it appears that the true proportion of pairs of SAT questions with the same answer is less than 20%. Since, and this is where you write your p hat, since p hat is equal to 0.18. So this is the only time you're going to use p hat until we get to step 4. That'll be the first time you use it again. All right, but what's the but here? What are we going to have after it? No? What did we do in a confidence interval? We said this was our best guess, Well, but what?
Probably incorrect.
Okay, it's probably incorrect, okay? This is our, it does appear, but this,
Well, because the other one says,
but it is possible, right? But it is possible that we got this answer due to sampling variability. In other words, maybe if I did another sample of 200 pairs of questions, I would have found that more than 20%. Okay, I would have found more than 20% have the same answer. So I will conduct, this is, we're doing a test. So we're not just calculating something now. I will conduct a one sample, and this is the key, a one sample z-test for P. This is the key. This is the type of test that we're learning today. This is called a one sample z-test for P. Okay, step 2, we need to name our hypotheses. State,
you have to write anything.
at alpha equals what? What's our alpha level?
0.01.
0.01. Okay. So, step 2 is state the hypotheses. Okay, so the null and the alternative. This is always what they look like, H sub 0, colon, and H sub A. So now we're dealing with P, the true proportion. So it's always P and P, it's always P equals, and then the alternative is, it could be greater than, it could be less than. So this is, we already decided at the beginning that our P is 0.2, and the alternative is that it is less than. We suspect, based on our sample, whoa, what am I doing? It's less than 0.2. Because of our sample being 0.18, we suspect that it's less than 20%. Okay, so now step 3, we have to check the conditions. Okay, so was it stated that it was a random sample?
Yeah.
Yes,
Yeah.
so stated as a random sample. Okay, and second, what's the second condition?
Less than 10%.
Independence, so we would assume that 200 is less than 200 pairs of SAT questions is less than 10% of all pairs of SAT questions. And the third condition, what's the third condition? Large sample size, which in this case is what? Thank you.
200.
How do you test for large sample size in the case?
Oh,
N times P
I thought you asked that.
is greater than 10 and N times Q is greater than 10. So N is 200 and P was 0.2. Well, that's, what's that? 40. And then 200 times, what's Q? 0.8. So 160. So both are greater than 10. So we can go ahead and do step 4, the calculation. Basically, step 4 is find the probability. Find the probability, which is the same as the p-value. Okay, I want you to understand that what you're doing in your calculation is you are finding a probability of getting an observed value as high or higher or as low or lower than what you did, assuming that the actual percent's 20%. So find the probability or the p-value. So we are finding the probability that, and this is the first time since up here that you use your p-hat, and the only time in the whole equation. We're finding the probability that our observed value p-hat was less than 0.18. How do you know what inequality to put in your probability statement? It's whatever one is in your hypothesized, your alternative. So you know to do less than because that's your alternative hypothesis. All right, so the probability that p hat is less than 0.18 is equal to the probability that, now, I need to change this into a z-score. Okay, I'm going to change this into a z-score. So the z-score formula, so now we're going to find the probability, we're going to change this, change to a z-score. So in other words, what would be the z-score for a proportion being 0.18, assuming that 20% is the true value? So the formula for the z-score, so now we're changing this p hat into a z-score, so the probability that z is less than, the formula is on the previous page. What's our observed p hat, our observed p hat? 0.18. Minus what's the hypothesized proportion? 0.2. And then we divide by the standard deviation, which is the square root of 0.20 times 0.80 divided by how many? 200. So the probability that z is less than, everyone should be practicing this calculation right now. You're going to take 0.18 minus 0.20 in parentheses, so work that out, and then divide by the square root. So begin parentheses, 0.18 minus 0.20 end parentheses, divided by the square root of 0.2 times 0.8 divided by 200. And I get that my z-score is negative 0.7071. So this would be on a normal curve. Z is the normal curve. So this is 1, 2, 3, negative 1, negative 2, negative 3. So this is your z curve, your z normal curve, where the mean is 0 and the standard deviation is 1. We want to know what's the probability that z is less than the negative, here's negative 0.7071. What's the probability that it's down there? So we have to type in our calculator. We'd go to the normal CDF command. And in this area, what is the lower bound? Negative infinity. So negative 99999, comma. What is the upper bound? Negative 0.7071. The mean is 0, and the standard deviation is 1. Okay, so the p-value is 0.2397. So now I need to make my conclusion. There's my p-value. Okay, it'd be 2.2398. Okay, so now we go on to step 5, and we need to make our conclusion. Okay, we have to decide, do I reject the null or fail to reject the null? Do I say it's 20% or do I say it's less than 20%? So I compare my p-value. This is how you always do step 5. You first say my p-value and my alpha. You write them in this order. What's my p-value? 0.2398. And what was my alpha level? 0.01. 0.01. What symbol would go in there to make that true? Less than or greater than? Greater than. So now if you go back to the other page in our notes where it said there's only two things that can happen. If the p-value is less than alpha, we reject the null. If the p-value is greater than alpha, we fail to reject the null. So this is, the p-value is greater than alpha, so we fail to reject the null. Now, the hard part of this is we made the decision. Now we have to translate what does that mean in the context of the problem. What does that mean in the context of the problem? So we cannot conclude, very good, we cannot conclude okay, very good. Can you say that again, Morgan, a little louder for everyone?
That 2 consecutive questions will have the same answers less than 20%.
Okay, very good. So we cannot conclude that 2 consecutive answers have two consecutive